When we map out humanity's survival off-world, the destination is almost always Mars. We dedicate billions to reaching a freezing, irradiated desert that has barely a third of Earth's gravity. Yet we completely bypass the planet right next door, a world that is a near-perfect physical match to Earth, with roughly the same mass, size, and 90% of our gravity. We ignore it because standing on the surface of Venus guarantees a rapid, violent death. Down at altitude 0, the temperature sits at a blistering 465 degrees Celsius. Because of the planet's dense atmosphere, that heat does not drop a single degree, even during its backward-spinning 243-day-long night. To put that thermal energy in perspective, if you dropped a solid bar of lead onto the Venusian dirt, it would instantly melt into a liquid puddle. The atmospheric pressure at the surface is 92 times heavier than what we experience at sea level on Earth. Walking around down there applies the exact same physical crushing force as holding your breath 900 meters deep under the ocean. Venus didn't start out this way. Millions of years ago, widespread, unending volcanic eruptions triggered a runaway greenhouse effect. This diagram shows how the resulting atmosphere, which is 96% carbon dioxide, operates. It acts as a one-way barrier. Solar energy easily passes down to the surface, but the resulting heat bounces off the inside of the atmosphere when trying to escape back into space. The trapped heat forces the surface temperature higher, which releases even more greenhouse gases, accelerating an unstoppable cycle until the oceans completely boiled away. The ground is permanently lost to us. Which is why, in 1967, astronomer Carl Sagan proposed that to survive Venus, we have to look past the ground and aim for the clouds. If you launch a vehicle exactly 50 kilometers straight up from that hellscape, you hit a startling transition. The temperature abruptly cools to a comfortable range between 0 and 50 degrees Celsius. The crushing pressure normalizes to match Earth's sea level, and the thick atmosphere above perfectly shields you from incoming solar radiation. This specific altitude is so hospitable that NASA engineers developed the HAVOC project, a concrete blueprint to build a colony of floating architecture suspended high above the danger. This model illustrates the core physics of Venusian buoyancy. The carbon dioxide in the planet's atmosphere is exceptionally heavy, while our standard breathable air is relatively light. Because of this density difference, a balloon filled with Earth air naturally floats on top of the Venusian atmosphere. We wouldn't even need to import our oxygen. Because Venus is closer to the Sun, a floating station receives double the solar energy we get on Earth. That power can be used to run electrolysis, a process that rips the toxic CO2 molecules apart to manufacture fresh, breathable oxygen. By simply lifting our altitude, a lethal planet suddenly provides the gravity, radiation shielding, and chemical resources to keep humans alive. But arriving in those clouds forces us to confront a discovery from 2020. Humans might not be the first living things to take refuge there. Scientists from Cardiff University detected a massive anomaly drifting in the Venusian cloud layer, a chemical called phosphine. Phosphine isn't a byproduct of lightning strikes or sunlight, and volcanoes cannot output enough to match the detected volumes. On Earth, this specific gas is almost exclusively manufactured by living, biological organisms. This points directly to the potential of extremophiles, microscopic organisms that have adapted to survive extreme conditions, living inside suspended droplets of corrosive sulfuric acid. The deadliest planet in our solar system might harbor the first concrete evidence of extraterrestrial life. If life exists there today, it originated on a much kinder world. Computer simulations from NASA's Goddard Institute indicate that Venus once had liquid oceans and a habitable climate for 2 billion years. That massive window of time was plenty for biological life to evolve, right before the runaway heat cycle boiled the oceans entirely out of existence. This makes Venus a dark mirror for us. It is planetary-scale proof that a habitable paradise can be deleted. By aggressively pumping carbon dioxide into our own atmosphere, we are building the exact same thermal trap that suffocated our twin. To measure exactly how close we are to that tipping point, global space agencies are actively preparing missions like Da Vinci Plus, Veritas, and the European Space Agency's Envision, all set to probe the Venusian clouds within the next decade. Studying the Venusian atmosphere clarifies the stakes for our own survival. This planet stands as the ultimate warning that habitable worlds are fragile, and we must protect the one we currently call home.